Hello and welcome to this final video on this series of coordinate geometry, and in this video we're going to look at using the objective line method to solve a linear programming problem. So a company needs to buy some storage units. There are two types available, X and Y. Type X costs £100 per unit and covers 2 meters squared, I should say of floor, and can store 3.5 meters cubed. Type Y costs £120 and covers 1.5 meters squared of floor and can store 3 meters cubed. The maximum budget the company has is £1,200 and the maximum floor space is 18 meters squared. The company wants to maximize storage. Let X be the number of type X bought and Y be the number of type Y bought. Write down inequalities to represent the total cost and the total floor space required. So let's have a think about cost to start with. So type X costs £100, so 100x will give us the price for X, and Y is 120, so that's added to 120y, and the maximum budget is £1,200, so that cannot exceed 1,200. And let's have a look. We could divide everything by 20, which will give us 5x plus 6y is less than or equal to 60. Okay, so that just gives us an inequality using the smallest possible integers. And then let's look at floor space. So what do we know about floor space? Well, type X is 2 meters squared, so that's 2x. Type Y is, where's that, 1.5, so add 1.5y. And the maximum floor space is 18, so that's less than or equal to 18. And I might actually double all these figures because then that gives me integers. And there I have my inequalities for cost and floor space. So that's the beginning of this problem. So draw the inequalities on a grid and shade the region that is not required. Okay, so let's just make a note of those two. So what do we have? 5x plus 6y is less than or equal to 60. And then we had 4x plus 3y is less than or equal to, give us 36. Yep, there we go. Okay, so let's draw these in. So we're going to use the same method as we used in the last video. So we're going to look at the coordinates where x is 0 and where y is 0. So when x is 0, y would be 10. When y is 0, x would be 12. And the next one, when x is 0, y would be 12. And when y is 0, x would be 9. So let's show these inequalities now on the graph. So if I look at my scale, we can put it up in 2, so that's fairly nice. Do the same along the x-axis. So 0, 10 and 12, 0. Okay, so ideally this would be a nice straight line, not too bad, but there we go. And it's got to be less than that value. So I'm going to shade out the region which it's not. And then 4x plus 3y is less than or equal to 36. So that's 0, 12 and 9, 0. And it's got to be less than that as well. Now, it's also worth considering some other inequalities, and that is that I can't have less than 0 of either of the types of units. So these axes form a natural barrier, and that's usually true in linear programming problems because it's usually fairly unlikely that anything makes sense with negative values. So we've got this quadrilateral. I'm just going to draw around it in a different colour just because help to make sense of the region we've got. So we have a quadrilateral here. And based on the information we have so far, everything inside meets those conditions. So it's going to be enough floor space and it's going to be within budget. But question 3 is where we really get to what's going on. So it says, write down the objective function for the volume of storage and find the combination of units that should be bought to maximize the volume for storage. Find this volume. Okay, so the objective function for the volume. So the volume V, I'm just going to go back to red for a minute. Okay, so the volume V, okay, that didn't work, never mind, we'll continue in purple. The volume V is going to be equal to, well, let's just go back and see what it said about the volume. So type X could store 3.5 and type Y could store 3. So the volume is equal to 3.5 times the number of X units added to 3 times the number of Y units. So this is what we call the objective function. Okay, so what we want to do is we want to find the equation of a line which fits this pattern. So I'm just going to pick a value for V for the moment. It's not going to be the answer I'm looking for most likely, but I'm going to pick V as being 10.5, which might seem like a weird number to choose, but the reason I picked 10.5 is because 3 times 3.5 is 10.5, which means that 3.5 and 3 are going to both fit exactly into or both fit into it, which is going to help me when it comes to looking at my coordinates. So what I'm now going to do is I'm going to plot the line 10.5 equals 3.5x plus 3y. So let's use the coordinates method as I used before. So that's going to give me 0, 3.5 and 3, 0. So 0, 3.5 is going to be about there, and 3, 0 is going to be here. Okay, so I've got this line. Now this is what we can call an objective line. Okay. So if we were to rearrange 10.5 equals 3.5x plus 3y into the form y equals mx plus c, the gradient of that line is not dependent in the slightest in what that value of v was. So any value of v is going to return me the same gradient. So if I had picked a different value for 10.5, I'm going to just get a parallel line. Okay, and so what I'm going to do is I'm going to look at that line, and I'm going to move it, and for this it's quite useful to use a ruler, which is going to be slightly difficult this way. So I'm just going to come out of this for a moment. Okay, so I'm just going to insert a line, and actually I'm just going to go over that line again just so it's nice and straight. Let's get rid of that old one. Actually, let's not. Let's just make that purple as well. And although we ideally want to use thin lines, for the purposes of showing it up, let's make it a bit bigger. Okay, so here we go. Now, keeping that as parallel, just going to make it longer as well. There we go, so that's still parallel. Okay, and now as I drag this line through this region, I'm increasing my value of V, and I want to keep increasing my value of V as long as I can. Okay, right, so at this point, I've passed through one of the vertices, so that vertex at 0, 10. I know that's not going to be my greatest volume. I'm going to keep going, keep going, keep going, keep going, and there we can see I'm passing through the vertex at the bottom at 9, 0, and I keep going and slightly past that. So at this point, I pass through the final vertex of the feasible region. So that line there represents the objective line with the maximum value of V. However, I have a slight issue here because right where that vertex is, I do not have an integer solution because it's not in a convenient place. But what I can do now is I can look along that line and I can see whether or not there is any vertices that pass on it, and this will depend slightly on my accuracy, but this 0.64 looks like a possibility. Okay, and also, in fact, I'm just going to go back into full screen now. Okay, and also this one down at the bottom looks like it could be a possibility. So let's consider those and see if any of these are a solution. So let's think about the 0.64. So the 0.64, let's test it in these two inequalities. So the first one, I'd get 30 plus 24 is less than or equal to 60, so it meets this one here. Does it meet the second one? 4 times 6 is 24, 3 times 4 is 12, so that's 36. Yes, it meets that one there. So the 0.64 does work. What about this one right at the bottom here? So possibly we're saying 9, 0 might work as well. Okay, so does this work? That would give us 45 plus 0 for the first one, so it works for that one. And it would give us, what's that going to be, 36 plus 0 for the second one. It works for the second one as well. Okay, so both of these potentially work. Now let's actually look at the volumes we got. Okay, so the volume is using our objective function 3.5x plus 3y. So for this, I'm going to do 6 multiplied by 3.5. So 6 multiplied by 3.5 added to 4 multiplied by 3. So that gives us a volume of 33 if I use the 0.64. And if I use the 0.90, I get 31.5, so that is lower, which means that this one is the one that maximizes my objective function. So the question says, find the combination of units that should be bought to maximize for the volume of the storage. Find this volume. So it's 6 of type X. It is 4 of type Y. And the volume was 33 meters cubed. And there we go. We have completed that linear programming problem by using the objective line method.